Hi everyone and welcome. In this tutorial, we are going to build a basic AI agent from scratch. No heavy frameworks, no black boxes, just clean, understandable code. We'll break down what an agent is, how it thinks, and how it acts. Then we'll write a simple agent step by step and I'll walk you through running it live on VS Code. By the end of the session, you'll understand the fundamentals behind agent behavior and how to create your own custom logic on app. Right, so let's jump right in and start building agent from scratch. I hope that you all have VS Code. If not, you can use any IDE, that is absolutely fine, but I will be using VS Code in this tutorial. You also need to have a Python 3.12.9 as a version at least, or the latest version of Python. And then what we're trying to do here is we'll build an agent from scratch that actually will help you understand how an agent works, what is an agent, how you can connect agent with different agents, right, how they communicate with each other, how you get a final response, how you connect with a tool, right. Before jumping on all the big things, I just want you to understand the basic of how to build an agent from scratch, and this is a very basic tutorial, and in the end you will be able to build an agent using LangGraph framework. If you do not know that framework, I'll still share the links of LangGraph and the other resources where you can go and learn or read about it. But then in this tutorial, you do not need to know a lot about any of the agent framework, right? Maybe it LangGraph or any other. What we're trying to do here is to tell you how you can build a basic agent from scratch without knowing those things, right? So what I'm going to do here is I will actually start building an agent, right. Before building that, let me quickly create a folder. I'm doing it from scratch in front of you so that you all understand that what we are trying to do here is, right. So let me create a new folder. Okay, so my folder name can be, let me do it can be a basic agentic framework, right. So let me do this and let me select a folder. Now what we are trying to do here is we will have a basic agentic framework folder. Now we will require a few of the files and the folder structure that you should follow in any agentic framework, right. So first, okay, before starting anything, right, let me create one important file that every developer understands, right, which will be your requirements.txt. Inside requirement.txt, today we'll only need a few of the packages. You do not need a lot of packages. You only need LangGraph and you need Agentic, right. So only these two will be used in this one. So what we'll try to do here is we'll have these two in the requirement.txt file, and then what we do is we'll first create the virtual environment so that you understand how the virtual environments are being created. So what I'm going to do is let me just open this. You will be in that folder. First option should be you create your virtual environment. So for virtual environment, you run this command. Once you have created your virtual environment, what you do is so what you can do is you can actually install all the packages. Those are there in the requirements.txt, and then you can run it inside this virtual environment. So okay, let it build that environment. Once that is built, first point is that you should activate that environment. To activate, there are different commands. You can use the source command for my Mac, and then you can use this one for activating your virtual environment in Windows. I'm running the Windows machine, and hence you see that. Now your main step will be to install all the packages in the requirements.txt file, right. So you can actually run this, and this will actually install all the packages, and in this case these are two important packages that we'll be using, which is LangGraph that you see, and then there will be Agentic, right. What are these? What do we do with that? We'll understand about it in the course today. Now what you need is you also need to understand the structure, right. So what we are going to do is we'll have one folder called graph, right. This will have all the information about the graph. We'll go through it, what it means, and what all information we need in this folder. We'll also have a folder to have all the tools, right. So what we'll have is we'll have a folder called tools, that will be needed for having all the tools. Okay, so here you see that your all the packages are installed, and it is installed in that virtual environment. You can see that this tells you that this is the environment which is an active environment right now. So what we do is we have graph as a folder, we have tools as one of the folder, right? And then what we will have is we'll have one other file which will be main.py, where we have the main code, right? So let me start and tell you how to build the graph and how to have those things, right? So before building the graph, let me build an init file, right? So I think you must be aware of that we should have the init.py. This is the init.py that you should have. Then we'll have another file, and let us name it as graph builder.py. And then you have here we will have all the code for building the graph. Graph also needs nodes, so let me have another file, let it name as nodes.py. And then the good part is that you will always have a state of what information where you are in the agentic system. So then we have to maintain the current state of the flow. So let me do it in the separate file, and let me name it as state.py, right? So I think broadly you will need these files. You will need init.py, you will need graphbuilder.py, you will need nodes.py, state.py, right? Now what we'll do is let us go through the graphbuilder.py, and let me initially start writing the code for this, right? So let me say, okay, from we have lang graph, which we have already installed, right? So you have lang graph dot, you will have a graph. Okay, before this I think you will need to okay, what we also need to do is, see, we need to select interpreter, we need to select the environment that we've created. So now once I'll create this, like select that environment, now you see that is gone, and then you'll actually have now if you write lang graph, it will start giving a suggestion, because now it understands that you already have that package, right? So now you have lang graph.graph, right? From this we will import two things. We'll import the state graph, and we'll import end. So what does it mean? We'll just go through it. So what we're trying to do is, we have graph class initialized here, and then we will import the state graph from that, which will maintain the state. And then we'll also do a graph.nodes. We'll include the nodes from our folder, right? So if you see that there is a folder, you have graph, you have nodes.py, and from that we'll import a few of the classes, right? Let me see what we can import here, but we'll import something there. And then we'll have from graph.state, we'll also import few of the packages, right? So before going to graph builder, then what we should do is we should actually define nodes and states, right? So for defining nodes, you can actually go to the nodes folder, and in this you will actually need to define a node. For defining a node, okay, I do not want this. So for defining a node, what you need to do is you can go to your file, you can import from graph, you need states. To define nodes you need state, and to define a state you need node. So that, like, it's a thing. Okay, so let me be very specific here. You have to define the state, then we'll define nodes, and then we'll build a graph. Let's do this way, so that will be helpful for you, right? So what we need is from Agentic, let me import the base model, right? So if you do not know about this, so you should just get a basic understanding of what Agentic is. It checks whether your output matches the format that you need, right? Or if it contains your object contains all the values that you need. What does it mean? I'll just let you know just in a second, or just in a minute. So what we're trying to do here is, we have Agentic import base model. We'll import from typing, we'll import an optional object. See, the reason for optional is that there will be some values, those will be optional in this. So what I'm trying to do here is, let's import this, and you'll get an idea of once I start writing the class, right? So what I'm trying to do here is, now let me write a class called agent state. This will maintain this state. It will check if each time whenever there is a state object, it should have all these values, right? So let me have base model, and what I'll do is, I'll have input, right? This input will be a string that will be coming in. I'll have tool, and it can be optional. It is not required to have tool every time, right? An agent can make a decision on its own, or it can have a tool associated with it. If agents have a tool associated with it, so we will have a string in it. So what I'm trying to do here is that it can be an optional thing, and by default it can be none, right? And then what I'm trying to do is I'll have a parsed task. It will give me what all task information. This is again optional, and we are using the typing optional. If you see, we have imported that. We've already imported that part. I'm so sorry, this is not optional. This will be string, and then by default this will be none, right? Then what we also need is the final result. This will again be optional if you do not have the result and there's an error. So we'll have an optional thing for result, and then we have none, right? So now what we've done here is we have defined an agent state class, which is your Pydantic, which takes a Pydantic base model, and it tells you that this object should have all these information. It should have input for sure, that is not optional, and other things are optional, like tool can be optional, your parse task could be optional, your result can be optional, right? Now this is a basic state that we have defined. Now let's go to the nodes, right? Now this is the important part where let me do one thing. Let me import state. So if you see, it is in the under graph, and I have a state class. If you see, this is state.py, and from that I'll import I think we have defined as agent state, right? This is what we have defined here. This is agent state, and I am importing that agent state. Now what we'll do is we'll make two thing, right? Like we have checked in that, right? And instead we have defined two things. We have defined parse task, we have defined tool. So let me define these as the nodes here, right? So there will be two nodes. We'll have parse task, we have run tool, right? So what we're trying to do is we'll parse the input that is coming in, because input will be in text, and then we'll try to parse that, right? So let me initialize the state. It takes agent state, and what it will return is again an agent state, right? Now what we do is we have a task. Your task will be defined as your state dot input. So if you see that your state will always have input that we have defined, right? This will always have input coming in. It is not optional. So we'll take that task as an input. Then what we'll do is we'll have tool, and now let us build a basic agent that will do a calculation for you, right? So what we're trying to do here is let us have if the calculator is needed, right? And it will be only needed if ne, let me do this. Let me have x in task. So what I'm doing is if x is in, so I'm just defining this, and this is a basic thing. You do not need to do this. It can be any task that you want to perform, right? But in this, for the basic understanding, I'm creating a calculator. So what I'm trying to do is, if in the task that is, or in the input, if the user asks for plus, it asks for square, it asks for multiplying, right? It asks for subtracting something, right? So what I'm trying to do is if there is a plus, or there is square, or there is multiply, on there is a minus, right? So if any of these is there, then what we'll try to do is we'll do we'll say the tool is calculator, otherwise the tool will have an option of none, right? And then what we do is we just return the output. We return the state dot so let me do a model copy here. The reason I'm doing this, one second, yeah, we have this, right? So what I'm trying to do is you'll understand this now. So what I'm saying is that you can have tool defined, right? Your tool will be the tool that is defined here, right? It can be calculator, or it will be none. Or what you'll do is you can also have parsed task, right? This will be parsed task, and then you can have your parsed it can be a task that is being defined here, right? So what we are trying to do here is that we will have an option of having this as the tool, and we'll define tool and parsed task, and this should be a dictionary. Sorry, this shouldn't be a list. It is actually a dictionary. And then let me remove this extra thing, right? So now what we're trying to do is we are returning the state with these values, which will have tool. So what we're going to do is we are updating the current state where the input remains the same, but your tool is either none or calculator, and then you have the parsed task, right? That parsed task will give you the input, right? It will have the input for now. Now let me also define another node that will actually run the tool. Now each node will have should have the information of what is the current state, because that is very important. And if it has the state, that will help it will actually help get you this thing, right? So what we are trying to do here is that let us create another node which is run tool, and then we'll define that, okay, if state dot tool that we've defined above, you can see that, right? And let me do this. If it is calculator, so if it is calculator, then what we'll do is we will actually check whether the task user is asking is calculator, and then we'll get the result for this, right? Okay, so for this I think we should define a calculator in the tools.calculator file, right? So let me have a calculator file over here, but then that will not have anything for now, right? Okay, so let me see how we can build the tools, right? So let me again go to this, right? So currently you will be seeing that, okay, how you can actually from scratch build these things, right? The reason we do not have something already there for you that you can actually use, the thing is, the only reason that we are doing this is you should understand how we can actually build this from scratch, and that is like, what are the missing files, right, for each of the scripts that you see. So now what we are trying to do here is we will have calculator.py, and let me quickly build this class because that is needed. So okay, let me see, import, we can import for regex, we'll have import re, because we are building a very basic class of calculator, right? Now what we'll do is we'll define the process. Let me have a class called process. It will take self, it will take task, right, because the task is coming from the state that you see, because we will pass the task here. So what we're trying to do here is we have a process, we define the task will be the input, and then output will be a string, right? So let me write a code for this. Like, let's have try, we'll have try and task, because the task can be in caps also. So let me do this one, and then lower, and then what we'll do is we'll replace it. So see, we need to replace things like, if it is plus, then I'll replace this with a plus. See, you can have any function, you can actually have a tool, you can make an API call here, but then what we are trying to do is a very basic thing, and that's why you see that we are having a very basic functions here, but you can have your own API calls or any tool that you want to make, maybe a DB call, right? So that is up to you. So what we're trying to do here is, okay, let me also replace a squared one, right? Let me say, if you have a squared, then you replace it with how you do squared and this, right? Okay, so what we're trying to do is we'll try to see if if the task is having any string as plus, minus, or squared, and then we'll replace it by these values, right? Because we can actually calculate and do the math on it, right? So let me have an expression, let me have a okay, for regex what we'll do is, if okay, this, I think we can do this, then we should take, if we have, we have all the what is it called, if we have 0 to 9, and if we have any character, right? So let me okay, let me write this regex directly over here. So what it means is you'll have all this information, and then what we do is you define your task, right? So what we're trying to do is we'll have the expression from the task, and then we will eval that expression. This will do your calculation, and then finally once you have the calculation, let me return this result as a string. I'll convert it to string and return it. And then I think if I have an except, let me catch the exception. And this is a basic thing, right? You should have your own exceptional handling. Let me return okay, error as E. We already have E, right? Yeah, I think this looks okay, right? So what we've done is we have function defined for class defined for calculator, and it will take the task, it will lower and rename it with or replace it with the plus sign, minus sign, and the sign for the squared one. Then what we do is we have an expression that will take the task, create the equation, and then you finally eval that and get the result, and we are passing the result as a string, right? So if you see that the output should be in the string format. Now once we have this, let us go back to the node, and now here what I should do is, let me have a graph from, I'll have tools, right? Now tools is one of the folder that you see here, right? So what we'll do is we'll have tools dot calculator, and from that we'll import the calculator class. So now you have this calculator class, you have this object, you have a function. So if you see, the function is process, and then what we'll do is in this function it takes only an input, which is your task. So I'll take a parsed task, and this is the string that is going inside that function, right? Now once you have the result, what we'll do is we'll again do the same thing that we've done above. We'll do a model copy. The thing is to update the result. We want to update the state. So what we do is we have the result here. So let me okay, so let me do a result here, and inside the result let me have the result, right? This is the result. If it has if we do not have this thing, right? Okay, it is showing some error, and then error could be because again I think I've made the same mistake. This is again a dictionary because we are passing a dictionary here. I'm sorry, this is done, right? So now what we are trying to do here is we have a dictionary, we are returning this. If your state.tool is not calculator, you can actually have different else conditions, but if your state.tool is not calculator, you actually return directly an error in this case, right? So otherwise you can actually return any other thing that you want, right? You can return you can return another there can be multiple tools. You can one calculator, you can have an API call, you can have a DB call, etc. So if you have multiple tools, then basis the state and basis what tool information is, you can go to that. But in our case we are only having one, that's why we are just seeing if it's calculator. If it is not, then we'll say not applicable or tool found, right? So let me say that, and I'm missing this. So now till now what we've done is we have created a calculator. We have a calculator class. It's a very basic class. It will take task, it will return the string, right? Final string of the result. And then what we do is we have an agent state defined, and that state is a parentic class that takes input, and it will have tool, pass, task, and it will also have a result as an output. And these three are optional, and it is coming from the typing package. Then what we do is we've created nodes. We've created two nodes in this graph, you see the parse task. One will be of parsing the information that is coming from the user, and then second will be what tool to run, right? These are the two things we have done. Now we have all the things. Now let us quickly build the graph, and we will be good to run our basic agent, right? So in this we have parse task, graph.nodes, and what else do we have? We have run tool, right? So let me also import run tool. So I'll tell you how to build the graph, and then the graph will have the information of which node to call first, and then where to go and what path to follow, right? I'll also have an agent state defined. So let me quickly define a very basic graph function. This will be having a build graph. So for graph, first thing always should be to define your state. So we have already have a state graph. This defines, if you see, right, the schema that class that defines the state. A graph whose nodes communicate by reading and writing to a shared state, right? So what we're trying to do is we will define what is the state here, and we've already defined that state. We'll just use that state in this object, right? Then let us add nodes. Like in the graph, you all know that this will be having nodes and edges, right? So to add node, you have a function called add underscore node, let me add first node, which is parse task that we've defined, right? And the function of this node will be to parse the user information. Then what we will do is we'll add another node that will be run tool, which will help us running the tool or execute that tool function, right? Okay, this is what we've done now. Now let me define the flow. This is very important to define the flow, right? So what we'll do is we'll do again that object, and then we'll set the entry point. This is important. This will tell you where to start, right? What we're trying to do here is it will tell you where to start, what is your initial node or first node when the user input comes in our case, what we've done is we have parse task as the input. Okay, now we have parse task as the entry point as an input point. Then as I mentioned, right, the graph will always have nodes, and it will again have edges to connect to each node, right? So this is like you want to make an edge from parse task, which is your first node that we've defined, and the edge is created from parse task to run tool, right? So what we are doing here is we have created two nodes, parse task, run tool. These are coming from the nodes that we've defined here, and then you have the set entry point. You are actually entering from the parse task, and then you are adding the edges between the nodes, right? You have connected parse task to run tool, and then we'll add another final edge. That final edge will be from your tool, because your tool is the last node that will give you the result of the calculator, and then you define end, right? This is an object that is coming from the LangGraph class, if you see above. So what we do is we use this will tell the graph that okay, now that your graph is having your entry point, and it also knows where to end. So your graph is from start to end, and then once this is done, you actually compile your graph, and this will be an object that will have all the information, right? So this compiled builder.compile will have the object, will have all the nodes information and your entire graph flow, right? The only part now remaining is to create main.py. So for creating main.py, what we'll do is from graph we have graph builder, because that is the only class that we need to call. Internally it is already calling other classes, right? So we have already introduced graph. So let me have name, okay, and the name should be, oh sorry, it should be main. Let me name it as main, right? And then what you see here is okay, so what we want to do here is you will have to define your object, which is like build graph object, which is the graph object that we've built, and then you have finally the result that will be coming as a graph invoke, right? So what this is like an invoke function, right? So if you see on the right, it tells you, right, it will take input, it will take you can have your stream mode on, you can have all those things, right? But we are making a very basic invoke where we will give an input, right, and we'll give the input from the user. You can actually take input from the user as well, but right now for a basic understanding, let me directly pass the dictionary. You can actually read the dictionary from user as well, right? Let me ask a very simple question, right? What is 2? But okay, let me complicate this. 2 plus 7 squared, right? This means 7 squared is 49 plus 2 is 51, right? So it should give you an answer as 51. Once you have this, let me write a print statement. Let me do a backslash and say this is a final output, and then let me also print the final result, right? So this should actually take this as an input and should answer whatever final calculation is, right? Let me run this file and see if we actually get the specific thing or not. Okay, so it's saying that from graph.graph_builder we cannot import graph build graph. Okay, why is that? Let me just check graph builder. It do have build graph. Let me just check again. You have graph.graph_builder and you import build_graph. Okay, I understand it is not taking the path from this, so that is okay. Okay, so I think it's because it's not taking the route. This one, let me try to check if this one takes still the same. Okay, so I think it's not taking this graph class as this. Give me a minute, let me try that. Okay, so I had taken few minutes to check why it didn't run. The reason was that the root directory that you have, the root directory doesn't have the path, and that's why it was not picking this. I have changed the root directory. I have moved it to a specific folder instead of desktop. I've moved it to the folder where it has a Python base root defined already in the Windows. So now if you see, what I'll do is I'll run this main.py, right? So what we are trying to do here is okay, sorry, I need to activate the environment. Let me first activate the environment, which is very important, otherwise it will not find the packages. Now what we are trying to do here is, right, we can have python m and main. Now if you run this python m.main, what you see is your final output is the input that you gave, which tool it called, and what is the final passed passed task, and the final result is 51, which is in the string. It's coming from the calculator class, right? So what we have learned in this small and a very basic tutorial is how to build a LangGraph agentic system from scratch that calls a very basic tool, right? So what we are doing here is, I'll just recap very quickly. We started with defining the requirement.txt. We had only two packages, LangGraph and Pydantic. We then created our own virtual environment where we installed this requirement.txt, and then we have defined a structure of our agentic pipeline, which has three folders: graph, tools, two folders, graph and tools, and it has main.py file, right? In graph we have defined three files, which is very important: graph builder, nodes, and state, right? What we are trying to do in the graph builder is, we have build graph, we have state defined, we have all the nodes defined, and then we define the flow. So the flow you see is that you have an entry point as past task, that's your node. Then you have an edge from this node to the another node. We have defined the nodes first, then you define the flow, and then you have a final edge from your run tool to the end, so that we know that this is the start point and this is the end point of the graph, right? This is nodes.py, where you've defined both the nodes that you have defined there, which means these are the functions. Your first node is a parse task, and remember, this is very important, your each node will take the state, because it has to know at which point in graph what is the state and what is the input on which it has to work, right? So what we are trying to do is, we have state for both the nodes, and then in the node we define whether the tool needs to be called or not, right? For parse task, we define the input, we say if it's calculator, if these are the few strings mentioned, otherwise return none. And then what we do is we define a tool node, right? We also define a state, and this is a Pydantic class, which is very important. You have agent, state, base model, and you have what all information you need. You need input, you need tool, you need parse task, result, etc. And then the important is the main.py. Main.py is very simple. You can actually invoke the stream also, like when I was going through the this function, it also has an option of having the streaming output, right? But what I've done is very basic, where you take an input as a JSON. You have an input key that has the value as what is 2 plus 7 squared. You can take actual user input also in this main file, right? So what you're trying to do is, you have your graph builder here, you take the result, and finally you print the result, right? So this is like a basic agentic flow. You see that the final output is input, what is this, your tool, your parse task, and finally the result, right? This is what we are trying to give as a final output, right? You see, this is the result, and that result is getting appended to that, right? So this is the basic structure. I hope you like this one. I hope you enjoyed the session of Agentic AI, right? And this is a very basic tutorial. Follow our channel. I will be getting you the actual agents that can be built at a higher scalable level, that can actually go into the production as well. We have different agentic ways of building agentic systems, like you have a supervisor, you have different sub agents, then you have plan and execute kind of an agents. you can learn all these about in LangGraph. Then there are how you can do a crew.ai, how you can use autogen, right? So all these things will be coming up very shortly, so please subscribe to the channel and you will be getting more information on agentic AI, right? So instead of just hearing agents as a buzzword out there in the market, out there in the data science community, what I'm trying to do is I'm trying to break it down to a very basic level where you can actually write a basic Padentic class. You can write simple nodes, edges, and then how to connect to it, right? But this is not currently production scalable that I have shown you, but then there are ways to maintain and scale it. There is a Redis queue, you can store the memory. There's a static memory, you can have a dynamic memory, how you can store all these things, right? So for all this you have to follow the channel, and very soon I will be coming up with the higher or the next level of how to build agentic system, right? I hope you liked it, I hope you all enjoyed it. Please click on the like button, or please mention any query or feedback you have in the comment section, because that will be very helpful for me. Thank you, and see you very soon.